Adkins. I'm the cartography lead at Meta.
James Anderson, research scientist at Meta.
And we're going to talk about querying the Earth with a thing we developed called Earth tables. So we had a lot of internal use cases at Meta, developers, engineers who wanted to use OpenStreetMap data that we use a lot with daylight, and just wanted to be like, I need all the parks in the world from OSM, but if you work with OSM tagging, there's a high barrier to entry there. Getting all the parks could be rather complicated. You'd have to know a bunch of different tagging methodologies and map them differently in different parts of the world. A lot of people inside of Meta use base maps, kind of a cross-functional tool for people to do all kinds of work. And we needed to develop something that was simple for people to use. Of course, it needed to be a single table, something easy to understand for people who didn't know about maps, didn't know about OSM, just wanted data. So we developed this thing called Earth tables. It's an extension of our existing process of cleaning OpenStreetMap data and putting it out as part of the Daylight project. So we took our multiple years of cartographic data, like making map tiles really simple for our maps, and we took all that kind of methodology and logic we had built into our tile schemas and just kind of pushed it down the pipeline a little bit so people could take advantage of that without having to know how to query tiles and all that. So we just kind of converted it to a table. So you can see a quick example here of what a building, this building has 2 tags, warehouse levels. We've given it all kinds of stuff. We know it's industrial, it's a warehouse. In general, we'll do a couple for examples. So Earth table fits into all of our maps at Meta that are served out across Instagram, Facebook, WhatsApp, Mapillary, a ton of other places. It's available to the community as an extension to Daylight. And OSM users who contribute to OSM, contribute to Daylight, contribute to Earth tables. And we've also done a bunch of cartographic improvements to it so that you can actually make global base maps with it. So we validated like building height information so you don't get like 400-meter tall buildings and stuff. We simplified place names so that if it's like urban, settlement, local, and we've developed classes for all those. The Bing tile quad key to every feature, which is important for like doing a bunch of quick searching. Added a lot of Boolean evaluations, like this is indoor, this is intermittent, this is bridge, just true falses for a lot of those instead of having to know several tag combinations.
Yeah. So where can you get the Daylight Earth table? Daylight and the Earth table, the Daylight Earth table, are available as part of the registry of, or they are part of the registry of open data at AWS. So these are hosted on AWS, and the idea is you can work with them in situ in the cloud. So yeah, there's some really big Parquet files on S3, but you don't have to download that or worry about that. You can just access them right there in the cloud, and you're only paying for the data that you scan, which is a very nice pricing model. It's very cheap to do some of this analysis and extraction. So we'll take a look here. You can go to daylightmap.org/earth, see more information about each of the themes, and there's some like feature counts on what's actually in there. This is all it takes to get started. So you do have to have an AWS account to access these files, the Parquet files that are on S3. But you go to the query editor, copy and paste this query from the website, and click run, and that's it. So we can start to look at the data here. Here we've got the query at the top. We're extracting from the Daylight Earth table the themes building, and we want to know buildings that are in land use areas. So here's an example where we've gone through and pre-computed for every building and attached a tag to that building on what the actual tag is in OSM, if there is any, for the land use that it's sitting on. So we've done that for every building and all the land use in OSM. And we can see we get a building that just is a general building, or do the stagnant building equals yes, comes into our class, it's like general, and you can see the original source tags, and then we also have the quad key attached to everyone and some information about the building. And you can do some really quick analysis like with the quad keys, which is really nice. So using like wing quad keys, this is surface area of golf courses around the world. It's kind of fun. I don't know Japan had so many golf courses. Learned that this morning. So thank you.